Hey you guys, we're in chapter 11, section 3, and we're looking at surface areas of pyramids and cones. So our first objective is I can name the parts of a pyramid or cone. That's just vocab. The second objective is I can find the surface area and lateral area of a pyramid. Now here we're going to have a couple of formulas we need to remember. And lastly, I can find the surface area and lateral area of a cone. So again, just a couple more formulas. So let's check out this vocab. First, we have a pyramid. A pyramid is a polyhedron in which one face, and this one face is specifically the base that we're talking about, can be any polygon, and the other faces we're talking about here are lateral faces, are triangles that meet at a common vertex. And this vertex is called the vertex of the pyramid. Next, a perpendicular segment from the vertex to the plane of the base. Well, the hint here is perpendicular segment. We're talking about the altitude. So looking at the diagram over here, here's our altitude. It goes from the vertex to the plane of the base. And it's perpendicular. It creates this right angle. Now the height down below, this refers to the length of the altitude. And last vocab, a regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. Not supposed to say isosceles. Let me try that again. Isosceles. Alright, now actually we have a little bit more down below. We have up here, we have the slant height. We have the slant height down here, and we have the height up here. So we don't want to confuse the two. The slant height refers to the length of the altitude of a lateral face of the pyramid. So over here in our picture, here's our height from the vertex to the base, and then our slant height is from the vertex going along a lateral face. So lateral face is what you want to fit in here. Alright, moving forward. Actually, before we move forward, check out our diagram here. For height, it has the letter H, so we use H to represent height. And for slant height, we have the L, the lowercase cursive L, to represent slant height. So that's something you should add to your notes over here. So right next to height, we can write H, and next to slant height, you can write that cursive L. Okay, now moving on. The two formulas that we need to know when working with a pyramid are the lateral area and the surface area. So first let's check out the lateral area. Now a lateral area of a pyramid is the sum of the areas of the congruent lateral faces. Below I have this diagram of a net, and this is the net of a square pyramid. Now if I want to find the area of each lateral face, then I would be finding the area of each of these triangles here. These are my lateral faces. And we know that the area of a triangle is half the base times the height. So we'd say half times S times L. And then we would add that to half times S times L, and add that over here, and add that over here. Now that actually, to write it more simply, is just 1/2 the perimeter of the base times L. And remember, L stands for the height and the slant height, not just height. Slant height, remember, it refers to the height of the lateral face. So here's our formula for lateral area. 1/2 times the perimeter of the base times the slant height. Now let's look at surface area. The surface area is the sum of the lateral area and the area of the base. So all we have to do here is take what we found for lateral area and add the area of our base to it. Now the area to the base will depend on what our base is. In our diagram we have a square. So to find the area of a square is just length times width, or base times height, however you want to say that. But depending on if we have a different base, if we have a triangular pyramid or a hexagonal pyramid, then the area of our base would be found differently. Alright, so let's get into some examples. This says, using formulas to find the surface area of a pyramid, follow the steps below. So step 1, write the formula for surface area. Alright, well we just saw on the previous page that surface area is equal to the lateral area plus the area of the base. Alright, step 2, substitute the formulas for the lateral area and the base. Alright, well for lateral area we know that's 1/2 area of the perimeter times the slant height. And then the area of the base, well, our base here looks like it's a 6-sided figure, so we have a hexagon. Now in all of these problems, we're going to assume that our pyramid is a regular pyramid, unless it's stated otherwise. So always assume a regular pyramid. And again, this is unless it's stated otherwise. So it's not stated otherwise, so we're assuming that this is a regular hexagonal pyramid. So the base, or the area of the base, would be found by 1/2 apothem times perimeter. Alright, step 3 says substitute values into the formulas. So now I need to substitute in. So I see that I have 6 inches for each of the sides of my base. So my perimeter would be 6 times 6, so I have 36. So I have 1/2. My perimeter is 36 because there's 6 sides. And my L, remember that refers to the slant height. So we see my slant height right here is 9. Plus 1/2 the apothem. Here's our apothem. It's drawn already for us. And here's the arrow letting us know that this length is 3 times the square root of 3. So the apothem is 3 square roots of 3. Notice I'm putting this in parentheses since the 1/2 and the A and the P, they're all multiplying together. And then perimeter, well, we had that before, so 36. And now last step is just to calculate it. So just throw this into your calculator. If you throw this into your calculator, you get 255.5307, so on. So we're going to round that to the nearest whole number. And we're going to say this is approximately 256 inches squared. And that's our answer. And we're done. So I want you to do the same thing below. I want you to go ahead and you try. This says a square pyramid has base edges of 5 and a slant height of 3. What is the surface area of the pyramid? Notice here that you have a square pyramid. So even though you don't have a drawing, it lets you know that your base is a square. Lets you know that the edges of the base are 5 and that your slant height's 3. That's really all you need to know. Now let's talk about cones. So a cone is a solid that has one base and a vertex that is not in the same plane as the base. Now the base of a cone is a circle. Now in a right cone, the altitude is a perpendicular segment from the vertex to the center of the base. So we have a diagram over here. Here's our cone. Notice here's our altitude. It's going from the vertex to the center of the base. Now from that center of the base to any side of our base is our radius. Center to any side of the base is our radius. Notice for altitude it has an H right here. The H represents the altitude because it's the height, and the height is the distance of the altitude, or the measurement of the altitude. Oh, so next, the height, H, is the length of the altitude. Recall that the slant height, referred to as L, is the distance from the vertex to a point on the edge of the base. So we still have a slant height. We refer to that as L, where H represents the height, which is our altitude. Alright, so here are the two formulas you need to know for a cone. We need to know the lateral area, and we need to know the surface area. Well, the lateral area refers to half the product of the circumference of the base and the slant of the cone. Alright, well, you need to recall that the circumference of a circle is 2 pi r. And if you take half of 2, then you're left with 1 pi r. So that's why we have pi r times L, L representing the slant of the cone. Looking over at surface area refers to the sum of the lateral area and the area of the base. Notice our formula is the same as it was for pyramids. So we just take the lateral area, whatever that was, and we add to it the area of our base. Again, though, we have a circle, so the area for a circle is going to be found by pi r squared. So you want to keep that in mind when you're dealing with a circle. Alright, so let's find the surface area of each cone in terms of pi. So in our example, first thing we want to do, as before, is we want to go ahead and write the formula for surface area. So surface area is equal to our lateral area plus the area of our base. Now we want to go ahead and substitute in each of these formulas. So for lateral area, I know it's half my circumference, so pi r, times my slant height, so times L. And my base is a circle, so the area of that is going to be pi r squared. And now I just need to substitute in things. So I'm going to leave it in terms of pi, so I'm going to leave it as pi. My radius, according to my diagram, my radius is 15 centimeters. My slant height, again according to my picture, I have 25 centimeters. Plus, I have pi again, and then r squared. R we said was 15 squared. So now all I need to do is calculate this. So you can take out your calculator, or we just say 15 times 25, and we get 375 pi, plus 15 squared is 225, again pi, and we want to keep it in terms of pi. So these are like terms that has pi and pi, so you keep the pi, and you just add 375 plus 225, and we get 600. And this is centimeters squared. So our answer, our surface area, is 600 pi centimeters squared. Alright, this is your last problem. I want you to try to find the radius of the base of a cone that has 16 meters. Its slant height is 28 meters. So I want you to find the surface area in terms of pi. So doing the same thing above. However, you don't have a diagram here, but it tells you that the radius is 16, and it tells you the slant height is 28. So you look up at our picture up top, the radius would be 16, and the slant height would be 28. Alright, you guys, see you in class tomorrow. Hope you took good notes.